So my name is Prateek Nagras. I am founder of Technoyantra. It's a robotic consultancy, and I've started it almost a year ago. Before I did my master's in Germany and worked in Germany for a year, worked in Austria for a year as a robotics engineer, and started my robotics consultancy. And we wanted to start this series, seeing especially there's a lot of interest in robotics, and it's like obviously a very fast growing field, and people have a lot of, there aren't much resources for them to actually understand it better, get a feel of the actual live projects, talk to people who have like some experience in that, who can actually guide. So it was the idea of starting this interview series with some great personalities in field of robotics, such as Juan, who have also good robotics knowledge, as well as some solid open source contributions as well, especially with your Champ robot, as well as Linorobot, which is actually used quite widely for beginners. It's actually a very good tool. So yeah, that was the idea of starting this, and it's good to have you here. And now I think, and I have Vaidehi with me. She's a colleague here. She also has her own TechTackled initiative, which she'll just briefly explain. So Vaidehi, you can take over.
Hi, I'm Vaidehi. I'm a recent graduate mechanical engineer, and I'm enrolled for a course, for a master's course in robotics. I will be starting this year. I just created an online communication platform called TechTackled, which aims to unite specialists in robotics and other tech enthusiasts.
Right. Hi, I'm Juan. I'm from Singapore. I'm currently working as a full-time research engineer. In my full-time work, I work on multi-robot planning, multi-robot path planning. And yeah, I've been working on robotics for almost 6 years. And right now, on a side note, I'm working on some of side projects that I'm interested in, mainly on quadruped robots and locomotion, model-based locomotion, and as well as I'm starting to learn more about reinforcement learning and learning-based approach on making machines work. And since I think it's a really interesting domain, as deep learning is it's getting we're getting more people working on deep learning, and a lot of papers are conferences. Yep, and yep, I think that's more about me. There's nothing much.
Yeah, thanks.
So what exactly got you into robotics?
Sure. I graduated as an electronics engineer to begin with, fresh from uni. And then my very first job was I was actually I was working in a factory. And fast forward, so I joined this hackathon, and which led me into this innovation lab in Singapore. And my very first project was an autonomous drone, right? So the project was supposed to deliver a parcel from Singapore to another remote island nearby. And then from there, I started working on more drones, and eventually I moved on to mobile robots, right? And that's where Linorobot came in, and I did a couple more mobile robots for my full-time job. And recently I had an interest in quadruped robots, which has been a long-term goal of mine to build one and to embark on a challenging project. Yeah, so that's how I started, and yeah.
Could you talk more about the Linorobot? What exactly is it, and what the mission and the vision behind it?
Okay, so sorry, my dog is barking. Yeah, but anyway, so Linorobot started back in 2015, late 2015. So I just came back from DRC in the US. It was DARPA Robotics Challenge, and they've been. I saw ROS running a lot of. I mean, ROS has been running to a lot of robots, especially the humanoids, and a lot of ground robots in the exhibits. And so, sorry, my dog is barking. Anyway, yeah. And then when I came back, I realized that I think ROS will be something to put more effort in studying, and I think this is will be a great tool in my robotics endeavors. But when I was learning ROS, I thought that I needed a robot platform, hardware to run test some of the tutorials and run ROS applications on the physical hardware itself, right? So I started to build my small mini robot, and so I didn't had any plans to make it a huge open source project, but eventually a lot of students and a few people here and there asking me, how can we extend this to different kinematic models, and until it grew and started to support 4 kinematic models. And then I decided to build a community within the project itself. And yeah, now 5 years down the road, I think it's one of the mostly used robot-based, a DIY at least. I mean, for people who wants to develop their own small robot or use for prototyping, especially on the ROS ecosystem.
Yeah, I would like to add, it's a really good platform. So for people who don't know about it, you should really check it out. So usually when you start ROS, Turtlebot is one of the things which everyone knows and everyone uses, but for simulation it's actually good, but when you get to the hardware, you can't really get a Turtlebot that easily, and also it's quite expensive for everyone to use as a development platform. But Linorobot gives you can make it yourself. You can use off-the-shelf components. You can just change the components if you want according to your needs, and there's firmware provided for running your robot, and you can test it out in simulation as well as then try to implement it on your own hardware. So that is actually a really good platform for new people who want to start learning ROS and also want to work with hardware as well.
Yeah, thanks for explaining more. And to add up, to one of the inspiration of the design of Linorobot is, there was this NASA sample return challenge when I was starting the project, and then I started working on a Turtlebot when my first few tutorials was running on Turtlebot. But then I realized that hey, what if I want to run my own robot, or what if I want to do outdoors, or what if I want to do something funky, a different kind of kinematic model, what if I want to have a full control of my hardware, and what if I want to build a bigger robot, right? So those questions really inspired and made a big impact on the technical decisions on the how Linorobot was engineered, and how the whole documentation was written to cater for different types of users. You might be a beginner, or you might be someone who got experience, but want to somehow get your hands dirty again and build your own robot.
Yes, that's a really good initiative which you took upon, and it has been a great open source contribution. So I would like to thank you on behalf of the community for doing that. Yeah.
So you are an electronics engineer, and when you build a Linorobot, so were there any challenges you faced, particularly in the designing phase?
Sure. I think the biggest challenge here is to because I wanted to build a platform that caters for a couple of builds and different kinematic models. I think making it a generalized platform that will work on different robots and designing it in a way that you'll be agnostic to the hardware that the users might be using, and to make it work without being tied into a specific hardware. I think the thought process is the biggest challenge. I think after that, it's a very fulfilling. It's very fulfilling to to get to see what you have envisioned. So yeah.
We would like to know about your more recent projects, the quadruped one that you spoke about. So could you elaborate on that?
Sure. Yeah, so Champ is a open source quadrupedal development framework, mainly focused on helping researchers or and control engineers to design new algorithms on top of quadrupedal robots, and to provide the infrastructure for researchers who are interested to work on quadrupedal robots, right? So I started the project almost 3 years ago. I started off with collecting papers and trying to see which one is the most suitable paper that that actually suits the features and how I want Champ to be. And then when was that? 2019, I started to write the very first prototype and write some simulations, build the hardware. Yeah, 1 year after the software was finished, and now I'm looking for beta testers to keep the software getting improved and catch more bugs, and get more feedback from the users on how can this be improved upon. It's also been a long-term goal. I mean, when I started learning ROS, I was back in the US. So during the DARPA Robotics Challenge, so I was at this exhibition booth from MIT researchers, and then I saw their prototype. I believe it was MIT Cheetah One. So I always wanted to, it's always been a personal challenge to build one of these, and so that's one of the motivations that kept me going to finish the project as well, and as well as to provide of infrastructure for the community. See, we in the ROS ecosystem itself, we've seen a lot of different variants of robots, right? We have humanoids, we have boats, we have tons of AGVs and AMRs, we have drones, we even have space robots, right? But when I was building it, I haven't seen any, although there are available quadrupedal robots, but there wasn't any available open source controller and a simulation stack that will allow researchers to build their prototypes and write the algorithms. So that really motivated me to come up with this piece of software, that hoping that it might be useful for seasoned researchers who've been working on this domain, or as well as to help those who are newbies like me who are looking for resources to how to start, and help them to develop as a tool to develop their algorithms and applications that that they envision how be helpful for the robotics community using quadrupedal robots.
Yeah, that's really cool. One thing I would like to add is we'll add all the links for your projects in the article, and I would also like to add that you also gave a talk in ROSCON last year regarding your Champ project. So if anyone is interested in And if any of these the listeners are interested in learning more about in detail about the Champ project, you can also hear his ROSCON talk.
Yeah, you'll get more in-depth technical details on the talks. Yeah. So if you have if you want to get your hands if you want to get your hands on Spot Mini, Animal, C, and some of the popular quadrupedal robots that you see on TV, and you're starting to you have some interest in quadrupedal robots, yeah, you can give it a try.
Yeah. So, what are your thoughts on ROS and how do you use them in your projects?
Yeah. Well, so how do I find ROS? Definitely, I will be biased. I mean, almost my whole robotics career is based in ROS. So I think if you're someone who is thinking to learn ROS, I think it's a good tool to start to learn robotics. Well, my approach when I was learning ROS was, robotics in general was a top-down approach, and I think ROS is a good tool on learning robotics in a top-down approach where, because by using ROS, you get familiarized with how to write a piece of code using the APIs, and by doing so, it opens up to a lot of software and packages and algorithms that you don't need to write, and it's all there off the shelf and just works out of the box. So means from zero to hero, right? As in, you build a robot and straight away you can build a robot that can navigate from A to B and able to map its environment, right? And as a beginner, these are the fundamentals that are good to learn, and good to know that this exists, and I need all these components to, in order for the robot to move from A to B, I need a sensor, I need I need a orientation sensor, which is IMU, right? Or I need to know, now I know that there's this concept of mapping the environment so that the robot has to see what's the environment like, are there any obstacles, and using the map that I'm able to localize, right, and compare some of the features, and I'm able to roughly estimate where's my position in 3D, right? So you don't have, as a beginner, you don't have to, learn all these, but it gives you an idea of what you need, what are the tools and what are the things that you need in order to build a robot, right? So a top-down it'd be good for a top-down approach. And then as you progress and find your interest, then probably that's where you can start to focus a little bit more on the things or the domains that you find interesting. Like, for example, I want to focus on navigation. I want to focus on perception, right? And then probably I'll develop more localization algorithms, some SLAM algorithms. Yeah. And then as you progress, then your expertise become more narrow and towards your specialization. Yeah. So that's from the beginner's point of view, but of course for someone who uses it as a tool, I find it really good tool to in terms of standardization and reusability of code. Like let's say if you find a piece of code that was written 10 years ago, most likely you'll still be, it's not 100% it will work, but because of that standardization and the idea of ROS messages and the topics, most likely you'll be able to port this piece of software 10 years after the code was written, right? And as someone who has written that piece of software, it will be it would be great to that software can be used 10, 20 years after you have written the software, right? Of course, not to mention the bug fixes and the feature that's being added, but as a and as well as being hardware agnostic, since we do have standardization regardless what sensors you're using. So it's really a great tool to to use, right? And it really abstracts the software from the hardware itself. Although I also heard some thoughts from some of the research community, especially in the deep learning community, where most of them are not really a fan of ROS, for the reason being that I think they prefer to have a more simplistic way of doing things, and they can straight away focus on the research that they're working on. And yeah, I mean, I hear a lot of comments that, oh, before I even start to run my robot, I need to do a ROS launch file. I need to deal with this API. I need to deal with the complexities of installing ROS. But I mean, it's just on the beginning part of the learning, right? I mean, we all know that the learning curve might be really steep, but after, I think once you overcome that challenge, just goes seamlessly, right? But it gives you all these benefits from those trouble, like your standardization, your comms, code reproducibility. You have a great community of thousands of roboticists working on software and helping each other to improve the framework itself, and as well as putting more tools on top of the framework, which of course you can use as well, right? As a roboticist. Yeah. So all I can say is a really great tool, and I think if ROS skills pay the bills, right? So I mean, as I mentioned, you will be very biased. But nonetheless,
yeah.
I think it's really a great tool. So I'm really looking forward to ROS 2. As I told Patil that I've been looking at the API, and I'm really excited to do more parts of my previous projects to ROS 2 and see what ROS 2 has to offer for us, right? I mean, it's really an exciting time. It's like the feeling is like when I was learning ROS 1, 5 years ago, and you have the same feeling. Oh, you got that excitement that that's how it works. So it's back to but of course it's also back to zero, where all your tools are like wiped out and you have to redo again. And yeah, but that's part of the process, right? Yeah, I mean, that's what I've always been telling people to, why you need ROS. I think one of the most common comments who are trying to learn ROS is that I think the tutorial is there, but I think we like this document that explains why do I need to use ROS. So I think that's the most common feedback from people who are trying to learn ROS. So it's like, yeah, the tutorial is there, but I think why do I need to do this part up? Or I mean, as a beginner, it can be overwhelming, and the concept of some of the tools being implemented in ROS itself, right? It can be overwhelming for people who are trying to learn, right?
Yeah, people are not that familiar with Linux as well. So even that is a place. Now with ROS 2, newer versions now they are supported for Windows, but even when you want to start, they are afraid of getting into Linux, even familiarizing with that aspect as well. So there's a lot of initial investment, and people are used to usually double click on Windows and the software should be installed and it should run, and that is never going to happen when you are learning ROS and using ROS. So you should be ready to get your hands dirty, dig a bit deep. So that is also an advantage and disadvantage of open source. So it's not like you'll get a perfect document and everything will work as it is. There are anyways people who are actually doing that in their free time or contributing to the open source development. So you also should be ready to take efforts to actually make use of that and get into that in more detail.
Right.
Okay, so any parting lines for the young roboticists out there who are just starting out?
Sure. I think the best way to learn robotics, or I think not just robotics, but any domain, is to work on projects that interest you. This way you won't get bored, and you will keep moving, and keep on digging things, and keep interested. It will keep you'll keep getting interested on the topic, right? And then eventually you'll become an expert, and then next thing you know, you've been building complex systems, right? Um, and as well as to, I think, really focus on a certain domain. I mean, it's good to start off with a very, very broad knowledge, right? But I think later on, as you eventually grow as a roboticist, I think it's good to focus on a specific domain, as it can be a very it can be a very broad domain, and you will tend to overwhelm, right? A lot of hype happening now. You have AI, you have deep learning, you have reinforcement learning, and you can get very excited, and if you don't really focus, I think it's really hard to be an expert, or to gain a specialization in a specific topic. And as what I've seen so far in the labs, in the research labs, and in R&Ds, is that they don't really require you to be a roboticist who knows everything, but it's good to you can solve a specific problem, who gain years of experience on solving specific problems, right? I mean, and by focusing, what I mean by that is that aside from your reading and the materials that you do, you learn, as well as you have to leverage on libraries and frameworks. Like as a carpenter, right? You don't build the hammer, you don't build your screwdriver, right? So you leverage on these tools, right? So you focus on what you want to do, and then get all these tools. You buy it from the hardware, right? And then you start using these tools and to build what you really want to build, right? So with this, what I mean is that if you can use a framework like ROS, or if you can use like a deep learning framework to expedite the work that you're doing, yeah, please do so, right? So same thing. You don't expect yourself to build TensorFlow yourself, right? Or to build or reinvent the wheel and build another ROS framework. And next thing you know, you've been building your work for 10 years, and you haven't even done the product that you're trying to achieve. So yeah, it's always good to do a sweep of what are the available tools out there, that would fit into the component or the block that you're trying to build, and then from there you can focus on what you're trying to achieve, right?
Yes, no, got it.
Yeah, so I mean, that's what really inspired me to build Champ as well. So I realized that although quadrupedal locomotion can be a specific domain, but that domain itself it can be very general, right? I mean, it's the same as building a mobile robot. So yeah, my thought process here is that if you want to work on a specific module on that quadrupedal controller, you don't need to worry about setting up the simulation stack and putting up all the navigation and do post estimation. The post estimation is there. All the common filters and localization algorithms are there. So yeah, you can straight away focus on the development and the idea that you're trying to prototype and build, without thinking about how am I supposed to write this gazebo, write the UIDF for this robot, or even find what would be the suitable tools that can be useful for this. Yeah, so it's the same thing. Whatever you're working on, it's good to, as what you mentioned, to look at libraries that you can leverage on.
Yeah, so I think that's it from the questions.
Should conclude. Yeah. Okay, so
Sure.
Juan, thank you for your time. Thank you for this amazing.
Thank you. My pleasure.
And how do our readers and everyone who listens to this, how do they contact you?
Yeah, you can give me you can give them my email perhaps. I mean, I'm on Twitter. I'm on Twitter. Or you can. I'm on GitHub. I don't have a LinkedIn page, so I'm usually on Twitter. Yeah, I find it a good platform to look for resources and most updated papers out there. Yep. Just go to my page and ping me there. Yeah, I'll be more than happy to hang out.
Yeah. Yes. So thank you.